So this is the institute called Karolinska Institute. It's very prestigious in medical science. At least everyone they know about this institute because this is the institute which gives Nobel Prize every year in medicine. So we have Nobel Forum in this complex, and every year 50 professors of KI in Karolinska Institute will decide who will get the Nobel Prize. So exactly 3-4 days after, like next coming Monday, the new announcement will be for 23 medicine Nobel Prize. So it is fixed every Monday of first Monday of every October. So it's very unique in that way. So this is why I'm showing this picture. Karolinska Institute is huge, but this is the Nobel Hall. So this is the only event where it is public. Rest all events of Nobel Prize is on invitation basis. So this is where, for the first time, Nobel laureate will tell the whole world what they have done and why they got Nobel Prize in simple words. So because this is for everyone to come, people from any field can come and attend this event. So this is the lecture hall. So this is how it looks in summer. So this is how it looks in winter, because Sweden has completely vast difference in terms of weather, like very cold in winter days. This is how it looks in spring. This building is the Nobel Forum. The small building on the left-hand side you can see is the Nobel Forum. So 50 professors of KI will vote. So this is like no one can say who will get the Nobel Prize. It's based on the nomination and they have to vote. So exactly at 11 o'clock they will vote, and 11:30 there will be the announcement. So this is how this institute is so unique. So I come here to present some of my work which I have done in UTI. So UTI stands for urinary tract infection. So when we talk about urinary tract, so it starts with urethra. I cannot point it out, but it starts with urethra, then it moves to bladder, and through urethra it moves up to kidney. So this is the whole urinary tract. So we have kidney, we have urethra, we have bladder, we have urethra. So infection can happen in anywhere. Like it can happen only in urethra, it can happen in bladder, it can happen in kidney also. So when we talk about bacterial strains, some strains they only infect bladder. So we call them in medical terms cystitis. So they cannot go up. So they only infect blood. But some strains, some E. coli strains, and the main positive agent here is E. coli. So the E. coli, some strains they can move up using urethra. They go against the flow of urine. They can move up and they can infect the kidney. So these are very rare but very dangerous because this is called pyelonephritis. So this is a severe infection condition, and in most cases, from this infection condition, bacteria they go into the bloodstream. So once they are in the bloodstream, it will lead to urosepticemia, patient might die. So when we talk about UTI, it's a common thing. Like almost all females in their lifetime, at least they will complain once about UTI. And what we have seen in the clinic, because I come also from the hospital setup, I'm having dual affiliation with Karolinska University Hospital. So we have seen in most of the cases, the day we find bacteria, exactly the next episode of UTI, we find the same strain. That means that bacteria is residing within that patient for a really long time. We have a lot of antibiotics, even then bacteria reside. So when we talk about mechanism, this is very because unique, I would say, because mostly people think it's just a colonizer. It colonizes in the bladder epithelium and then we get infection. But somehow, in recently, we have seen they go also into the deeper tissue. So you see here, sorry, I cannot point it out because, yeah. So these are uropathogenic E. coli. They attach to this superficial umbrella cell. So just imagine this as a bladder. So this layer is where we have urine. These are superficial umbrella cells. They are bigger in the epithelial cells. They are mature. So their size is big. And then we have then transitional layers with very small epithelial lining. So these E. coli strains, they interact with the superficial umbrella cells. They attach, and through different mechanisms, they enter inside the we have pointed. Oh, it's okay. So they go inside the deeper layer of tissue. They make big colonies. You can see there like a bacterial clump called IBC. So they form bacterial. So what is unique in this case, being these are in umbrella cells, means in the mature cells, because when we pee, we excrete out our urine. So with that urine, we also excrete out the exfoliated like a lot of superficial cells. So if bacteria is in the first layer, then it can be excreted out also through urine. But sometimes they go into the deeper tissue. So when they are in the deeper tissue, so by the time these cells to be mature enough to be exfoliated, that window is 6 months. So that is the reason why we get recurrent infection after 6 months. Because to be exfoliated out means cells to be detached from our bladder, it takes nearly 6 months. So the cells need to be mature. So then some bacteria grow in the deeper tissue. We call them quiescent intracellular reservoirs. They are like small, very small colonies. We have seen in our animal model, they even change their shape. Bacteria will be even longer because just imagine the umbrella cells is a big cells. So they have like actin like this. So there are a lot of gaps. So bacteria can multiply. But when it comes to transitional layers, where cell size is small, actin is tightly packed. So when there is no space for the bacteria to grow, so then bacteria has to change the shape. So they are more elongated so that they can remain inside this tightly packed compartments. So this is how the mechanism works. So what is unique and why I'm working on this UTI? My specific area here is antimicrobial peptides. So when we talk about antimicrobial peptides, we can call them endogenous antibiotics. So these are like really small molecules, positively charged. They can bind to the negatively charged membrane. They can make pores in the bacterial surface. Bacteria will die. So that is how they act on the bacteria. So these are antimicrobial peptides. So lot of antimicrobial peptides have been discovered so far. When we talk about kidney, you see in the picture HBD1 like defensin 1, defensin 2, defensin 5, 1137. There are a lot of antimicrobial peptides. Ureter also different, bladder is different, urethra. But the work which I will show, my work, that antimicrobial peptide was not reported before. So that is why that paper also went into Nature Communication. So what we have shown here, because when my professor gave me this project, so he said you have to find a new peptide, but this is like a tremendous work. Like I cannot say which peptide will be active. So then I did some literature search, which peptide is active against E. coli, because this is E. coli prone disease. So then I found in 2006 from University of Kiel, Germany, one professor has done an excellent study. They have found psoriasin. Psoriasin is like psoriasis. When we have psoriasis, there is a protein called psoriasin, and that psoriasin is highly active against E. coli, not against gram-positive, against E. coli. So then I thought, oh, that psoriasin is not present in kidneys, not in ureter, not in bladder. So the report which are showing, so that is not reported yet. Then in squamous cell carcinoma, in bladder carcinoma, psoriasin is a marker. So they do, when they test bladder cancer in the clinical setup, they measure psoriasin in the urine. So that means our bladder should produce psoriasin, or else they cannot measure. And psoriasin being in the bladder should also act against E. coli. So that is how I made the connection. So this is how my work is: identification of different antimicrobial peptides, how to understand, how to find the role of those antimicrobial peptides, and to boost the mechanism, how do we target these specific uropathogens. Yes. 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 Because although we know a lot of antimicrobial peptides, even then we get infection. So my professor, who is in this committee, like also in the Nobel committee, she thought like there are antimicrobial peptides. They should kill the bacteria. Then we should not get urinary tract infection. So maybe then we have not found the right antimicrobial peptides. Maybe if you find a different one, it might have a better effect on E. coli, because whatever we have found so far are not 100% antibacterial in nature. That could be different reasons, because urine pH might interfere with this bacterial action. These antimicrobial peptides are short-lived. So a lot of other physiological factors are there, but they are not so so potent, I would say. Yes. Yes. Yeah. Yeah. So that group which I am talking 2006 Nature Immunology paper. So there they have compared psoriasis, LL37, defensins, and RNH7 major family proteins, and their efficacy what they have seen with psoriasis, E. coli is 90%, means we can eradicate 90% population. But when it comes to LL37, only 60%. Defensin fourfold low, means I would say 25% less. So although they are antibacterial, but not 100% potent against E. coli. That was the reason why we thought we should investigate on a completely different antimicrobial vector. So then to prove our concept, we use a model called diabetes. Why we were interested in diabetes? Because Karolinska University Hospital is like a hospital. So every research what they do is always linked with the patient. So they cannot take healthy individual sample for any analysis because they need to come to hospital so that they can isolate or they can take the sample. So we have to select one patient group. That is the reason why we have chosen diabetes, because this is the group where we see lot of recurrent infection, not just with UTI, any infection you name. In diabetes, the risk increases. So what we did a simple experiment. We started with human samples first, because that is the advantage in being in the hospital setup. Because normally in Indian research atmosphere, we always start with in vitro experiments, we prove the concept, we go to animal model, then from animal model, we go to the human sample. So what we have done in the here, we collected urine samples from healthy individuals and also those who are diabetic. So when we measure the psoriasis level, so this is the gene name of psoriasis, S100A7. So this is the diabetes group. So clearly there was down regulation of this gene. So at the mRNA level. And this experiment is unique. So we got the approval to do on 20 healthy individuals. They are pre-diabetic, they are not diabetic yet. We did this experiment. This is called hyperglycemic clamp. So we gave them glucose. 3 doctors were involved. Every 2 minutes, blood was coming out and it was completely recorded. So we started this experiment. We gave them 0-hour time point. So all these 20 individuals were having blood glucose 5.5, it's normal range. And then after 2 hours, the blood glucose went to 11 millimolar. And then we immediately stopped. So 0 hour and after 2 hours, when we increase the blood glucose, we see also in the serum psoriasis is less. So this is how we saw that high glucose is impacting psoriasis. We did this in animal model also. We used this type 2 diabetic model in the bladder. We see at the mRNA level significant less psoriasis. And when we did this immunohistochemistry, you see psoriasis is heavily loaded in the umbrella cell, but significantly less in diabetic mouse. So this is how we identified that diabetes compromises psoriasis expression. And then we did a small in vitro experiment here. So this is in normal uroepithelial cells. So we treated low glucose, high glucose, and then we challenged with E. coli. So now you can see this dotted line here. So this is after infection in normal glycemic condition. So when cells are normal, their glucose level is normal. When we add E. coli, they react to infection and psoriasis expression is increased. Whereas in high glucose condition, all these 2 lines below, they do not react to the infection because cells are so compromised. Even if there is infection, they cannot react to the infection and they cannot clear the infection. So this is how we identified, irrespective of any time point, we chose 15 minutes, 30 minutes, 45 minutes of challenge, because this is innate immune molecule, it should come immediately. mRNA is always ready. Once bacteria comes, we have seen LL37 also expressed within 3 minutes of expression, infection. 30 millimolar is glucose. So low glucose, high glucose. So then we, because as I mentioned, when bacteria comes, they need to, when cells needs to hold together so that they form a barrier called epithelial barrier so that bacteria will not make an entry. So for this epithelial barrier function, there is like a lot of tight junction proteins. I'm not showing everyone, I'm just showing only occludin, which is, we also found that in diabetes condition, occludin is less. That means cells are not tightly packed. That is why bacteria is making an entry. And the expression of occludin is dependent on psoriasis. Because when we knock down using CRISPR, psoriasis, we also saw complete inhibition of uploading. So in high glucose condition, when we treated with psoriasis peptide, we found uploading more. So this is how we have designed that work. And then we did a lot of animal experiments, 24 hours infection. You see a lot of E. coli infection. All these black dots are from diabetic animals. CFU load is quite high, 10 to the power 7 to 10 to the power 8. So after 24 hours of infection, and you can see in this immunohistochemistry, lot of these E. coli are red stem, a lot of E. coli throughout the bladder epithelium, which is absent in the non-diabetic condition. So diabetic condition also changes a lot of things, and most likely also some receptors. We have seen MRC1, caveolin, they are all impacted, and a lot of E. coli attaches to the umbrella cells of the diabetic condition. And what is interesting, so this is just after 24 hours of infection. So when we did for long term, 14 days, means 2 weeks for animals, normal diabetes mice, normal mice, they clear the infection. So CFU load was 10 to the power 3. So clinically, if CFU load is less than 10 to the power 3, then it is regarded as healthy mice, means or healthy individual. Whereas in diabetes condition, we could clearly see still the CFU load quite high, like 10 to the power 7. So that means bacteria are remaining in the diabetic mice for long term. Like this is where we have shown only 2 weeks. Just imagine the human setup also. So they cannot clear the infection, and this is what I have proposed in DBT, which was granted for ammonium sulfate. So this is how also we have seen after 14 days we could see, because when there is infection load, host will try to get rid of all these exfoliated or infected cells, because that is the host mechanism. So now you can see normal mice after 14 days, they have a very strong epithelium. This green is Europe epithelial cell marker, the Europlakin 3A. So you see normal mice, the epithelium is healthy and intact. You just see in diabetic mice. So because of heavy load of infection, although that mice is diabetic, so that mouse also wants to get rid of all these urine, like all these E. coli attached. So epithelium has also lost its integrity. So that also causes more infection. Because once it is out, this also gives the bacteria an avenue to go into the deeper cells. So this is like a constant process how it works. So a lot of mechanisms are not showing all these mechanisms, but we showed how it works, how can we improve the efficacy of these epithelial cells, compromised epithelial cells, and then what could be a possible drug candidate. And here we investigated on estradiol. Why estradiol? Because when we talk about UTI, although it happens in male, but high cases are only in females. So, and that too we have seen in post-menopause condition, the risk is even higher. And then estrogen is very low at that time. So then we thought, can we add estrogen to these high glucose cells? And interestingly, when we add estrogen, we saw increase in psoriasis. So a lot of factors involved, considering diabetes for a long term, glucose effect. Yes. 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 Completely two different things. We just wanted to, because we need to bring something, a drug, possible drug candidate or a molecule which can stimulate the psoriasis. Because if you remember the first figure, irrespective of time condition, always psoriasis was less. So we need a drug which can stimulate this compromised cell. So that was one work. Secondly, recently there was 2018 one study on, because when we have normal UTI, we go to clinic, we ask for some painkiller, we eat those painkillers. That happens here, that happens also in Sweden. So people go to supermarket, buy some painkiller, they eat it. So what a clinical study showed, if a normal UTI, normal means only limited to the bladder. So when they eat these painkillers, that compromises, because these are anti-inflammatory drugs. So they compromise the efficacy of the bladder, and bacteria, they moves on. So which bacteria was only limited to bladder, now because of compromised host condition, they can go up to kidney. So this is the data from Sweden, Norway, Denmark, Finland. So what they have seen, the risk is high. Well, you can see when they eat ibuprofen, means the painkiller, the risk is higher than the bacteria, means antibiotic. So it is not wise. So then we also thought maybe what is doing, maybe psoriasis is linked there. So then we used one COX-2 inhibitor, and then we also found psoriasis is less. So that is how, this is another paper which got accepted in Journal of Inflammation this year. So this is how we linked also not just diabetes compromising psoriasis, and to prove that psoriasis is the most potent antimicrobial peptide, we did this COX-2 inhibition also and measured the psoriasis. So a lot of mechanism we have shown, the ROS, the free radicals, the NRF2 mechanism. So a lot of mechanisms, I'm not going into those details. But what is unique here also, so we gave painkillers to animals. So we gave painkillers animals like 3-4 days continuously, and then we infected. And this infection is also transurethral infection. We do catheter-based infection. We take mice, we use small catheters, we put the catheters into the mice, and through catheter we load bacteria. This is how normal urinary tract infection happens also in humans when they are in the clinic. Like, just imagine a patient who is in ICU for a very long time, always catheterized. So this is always happen when you put the catheter. And so we have seen with only, although we did not reach significance, but our reviewer said, but that is fine because we could clearly see the trend. So lot of bacteria in the painkiller consumed animals. So painkiller also not always good. And this is again the estradiol which I just briefly mentioned. The estradiol. These are like ibuprofen. They are normally COX-2 inhibitors. But the painkiller which is available in market, it has both. Some are like non-specific, like COX-1 also, COX-2 also. But for experimental purpose, we have used, because we need to know which one is important, whether COX-1 or COX-2. So we use COX-1 inhibitor, COX-2 inhibitor, specific inhibitors, and we found COX-2 is playing the role. And that is how also the painkiller works, like through COX-2 mechanism. And then, one interesting thing, because our problem is we cannot boost the innate immunity of diabetes. And being in Karolinska, we are always fascinated about a new area when a new Nobel Prize is discovered. So 2018, it was given to hypoxia. I was there, so I wrote a grant to KI that I want to work on hypoxia. My boss had never worked in hypoxia. He said, no, we cannot do this. He was completely negative. I said, let's give it a try. Maybe hypoxia has some role. So what we did, because to prove it in patient, we have to collect the samples those who are staying in high altitude, because then only hypoxia can have effect. So Stockholm is only 9 meters high from the sea level, very low land. So we need also a high land, high altitude where we can collect it. So then I found in 3 places, Himalaya, in Ethiopia, and also in Bolivia, La Paz. They are like people living in 3,600 meters height. So, but again, to get those samples, we try collect from the Himalayan region. We could not, but La Paz government helped us. So we got these samples from diabetic patients, those who are in 3,600 meters height, day and day, like always, because they live there. So when we compare low land, high land, only difference, both of them are diabetic. You can comment on demography, but both of them were diabetic, lot of bad glucose conditions. But those who are staying in high altitude can produce more antimicrobial peptides. So that is the reason in high altitude we do not see infection. There are other risks like low oxygen related diseases, but you see those who are living in high altitude, infection chances are less because heat is playing the role, hypoxia inducible factor. So that is being and triggering a lot of innate molecules which is protecting the host, and that is true. So those are in normal conditions. But there they are not infected. That they are like normal, not UTI concept. Like it is just a bladder cancer setup. Normal patient, bladder cancer. They are not having any UTI or without any UTI history. So that is just. Yeah. Hypoxia. Yeah, hypoxia. Yeah. That we have not done. No. Yeah, that we have not done. So what I wanted to say from this figure that when we stabilize heat in high glucose condition, we could improve the expression of antimicrobial peptides. So then also again we did this in animals. And the problem in animals is they need 21% oxygen. ethically, we can give them maximum, we can go down is to 18%. We cannot go below 18%, then they cannot breathe. So, and also ethics committee says we have to keep them in 18% 5 minutes, then 21%. 5 minutes, then 21%. So, but that's not a proper hypoxia model. Proper hypoxia model is less than 3% of oxygen, which is impossible to do. So we did one chemical drug like called DMOG, which is like little bit like a hypoxia inducer in a normoxic situation. So when we infected, and when we gave this drug, DMOG, it had some protection. So now also you can see the same animals, DBDB, where we saw a lot of infection. When we gave them DMOG, significantly less. So this was in Journal of Molecular Medicine. So this is how we design our work. So I will go quickly now. So being in Karolinska, because Sweden again have 6 months of daylight, 6 months of night period. So in winter we have 20 hours of night time. So we do not see sun for 6 months. So then people there take all those vitamin D, and everywhere in food supplements, everywhere they get vitamin D. So then we thought vitamin D has some impact on these antimicropeptides or barrier function. So we found when we gave animals without vitamin D, like they are vitamin D deficient and sufficient mice, you could clearly see difference in occludin and claudin level. So these are dietary proteins. And then, because as I said, my boss is a clinician, so she always recruits patients. So she said we will start the study like where we gave like we did vitamin D for 3 months. We started Sweden's dark period. Some patients got vitamin D and some were placebo. And we started from November to February. So 12 weeks of continuous vitamin D. And then we collected bladder biopsy like from before and after. So interestingly, from those patients, like these are post-menopause, where they get a lot of urine infection, lot of cases of UTI. In those conditions, also vitamin D proteins. We have seen human crowding expression is high. So lot of factors, because our lab also looks for new drugs, not new in the sense completely new drug, but repurposing of drugs. Like yeah. Yeah, we have seen the mechanism. Like for example, hypoxia, when we talk about hypoxia binds to the LL37 promoter because it's a transcription factor. So it binds to the antimicropeptide LL37 promoter. That triggers LL37. So we have read a lot of we have studied a lot of mechanistic also. But here I'm only giving the brief. So then the commonly used drug metformin, which in India and also other places they are using. So that metformin also triggers LL37 or CAP, the antimicropeptide. So then we are looking for some new chemically synthesized drug. We designed a lot of small peptides. We contacted chemists. They designed some small peptides, and we have seen also these peptides that can kill these bacteria much better than LL37. LL37 is post-produced. We produce that. And then this area also I got because my group, like they are mostly UTI, but because during my PhD I had also a little bit experience of working on skin model. When we talk about antimicropeptides, we cannot give them to eat these antimicropeptides because they are toxic and they are like small fragments, so they can bind to any cell. It has a lot of toxicity. Although I work in antimicropeptides, but I can also say cannot be a drug candidate in near future. We need to really modify to reduce the toxicity of these peptides. So then we need to do something. So then the skin model is good because then we can go for topical application. So then it will not have that much of toxicity. So that is why we used a lot of antimicropeptides and the model to use this topical treatment. So what we have used, we have seen also there because skin again, psoriasis is highly expressed. We have seen some small fragments of peptides that can boost the innate immunity of skin. Psoriasis is more. So this is what we have seen. And interestingly, it was also seen in MRSA infected skin model. So this work, we went to, as you know, Journal of American Chemical Society is very prestigious in chemistry field. So we thought, okay, we will not use also peptide. We contacted the chemist in Stockholm. So we told that you design a gel, and gel itself is cation. So we do not want to add any drug there. So just the gel has to be cation. So they used a lot of amine groups. So they designed a gel which itself is cation. And here the cationicity they can measure. Like if they add more functional amine groups, they can say, okay, it has 64 cationic ends. It has 128 cationic ends. So when they designed this gel was highly potent, and it was zero toxicity towards the host cell, and it could trigger antimicrobial effects like RNA7 and psoriasis in the skin model. So this work was published in JACS. So we compared to the commonly used commercial gels, and it was showing even much better efficacy. And this work was also when it got into JACS. Soumitra was that time the Chief Scientific Officer for WHO. So when Karolinska highlighted this work, she sent a message to my boss that I think this is very novel because it can be thought in a different way for all type of bacterial infection. Like we are always looking for drugs. Maybe we use something, we change gels or something, we can use it for any other infection. So my future research plan, when it talks about DPT Ramalingam fellowship, so I want to study why some group of patients are having more prone to infection. So when we talk about diabetes, I am diabetic, you are diabetic, not 100 people are diabetic, but then not all are getting equal infection. Only few groups are getting infection. So why only few groups? Why not everyone? Repurposing of commonly used drugs. And I want to also study, considering diabetes, what I have seen in the clinic, that children, although they are diabetic, they do not get recurrent UTI. Only adults they get. So what is the difference between children and adults? Is there any epigenetic changes because of long-term exposure of glucose? Something is happening which is changing between children to adults. So I really want to investigate on different factors of this. And then also considering India, considering TB, I also want to do some antimicrobacterial effector function of macrophages so that I can boost the function of macrophage and it can be treated against TB as a new drug candidate. And why also it is important for India? Because this is also related to DPT. This I have taken from DST. Your government predicts by 2045, 140 million people will be diabetic in India. So it's a new challenge. Not just UTI, any infection, just with respect to diabetes. So poor metabolic control, compromised host condition, and there is no effective antibacterial, no new antibiotics, and again, a lot of drug-resistant bacteria. So the novelty of my project was when I proposed to DBT, it was so far no report of mechanism of recurrent infection in kidney. So that is what I want to highlight. Maybe I'm thinking there is some tissue remodeling, or maybe high glucose is acting on these peptides, maybe blocking the cationic activity of this peptide, and maybe their immunity. Something is happening. So, and then also I propose, if we know psoriasis is a marker, and if we know that psoriasis, if it goes down, infection increases. So can we design a testing kit, like those who are diabetic or having recurrent infection? So they can use their own urine sample to test to identify the risk factor. Like for example, if that psoriasis level is low, then 10 may be high risk. Maybe 10 to 15 medium risk, or maybe more than 50 is protected. So something like that. So can we design some biomarker and we can test from the urine also, and we can predict the risk. So these are my accomplishments from postdoc. I have in total 18 original articles with 12 first author, and then I have some nature communication, nature microbiology, JACS, all these ones. And then I must also highlight anyone point, I request all PhD students here, you apply for this Linda Nobel laureate meeting. It is a nomination based, you cannot go by your own. So here you get a chance to interact with 40 Nobel laureates for whole week from morning to evening. So DST from here is coordinating that. So every year DST is giving a call, so you can apply that. So that is a very good thing to participate. And then I have received several grants, means not several. I'm too young to get more grants. But I have received Karolinska Institute 2 grants and 1 DBT Ramalinga Sundar grant. So thank you very much for the attention. When we did the experiment, we increased the glucose, but we have seen, although glucose is controlled, but the HbA1c level is playing the key role, like considering diabetes really long term. So although they are well regulated in terms of glucose, but their HbA1c is quite high. So if a person's like HbA1c is high, it will also impact the psoriasis levels. Yeah.
Dr. Soumitra, can I ask one question? AK
Yes.
Singh this side.
Yes.
You know, in one of your slides, you said that at the high altitude, that peptides, their concentration is more antimicrobial, if I have captured correctly. Is it a confirmed information, or it is just a observation? Because it has got a very positive and long implications, because lot of soldiers are deployed in the high altitude, particularly of Indian Army. And that number is not there in any other country, one. And we have a lot of population who are Highlanders, who are staying there. So this is one of the future projects, if you don't mind.
This is
Or the prevalence of this, renal disease, what you had been working, renal infections, prevalence of renal infection in high altitude people.
Yeah, I think you are absolutely correct, because this is what also I mentioned to DBT that we can do something for the soldiers. And it is true. It is not only my data, there are other data also to support that innate immunity is more protective when people are in high altitude. So there are reports of different cytokines also. But this, again, these 3 regions only, like one was from the Ethiopia, one was from this Andes region from the South America, and of course, very few studies have been done in Himalayan region. But yes, it is not just database, there are reports to support that something is happening with respect to innate immunity.
Because when you say high altitude, is there any specific height, or because the high altitude, the height varies from, sometimes, the criteria is different.
Yeah, because the reason why I said high, because they are 3,600 meters high.
3,600 meters, okay.
Yeah, it's really La Paz, like it's really at high altitude. Why also on that? Because to have this hypoxic factor, when we talk about in vitro condition, it has to be always less than 3% of oxygen. And when we measure the oxygen concentration in La Paz, it is 18%.
Okay. Now it's clear. That's what I wanted to ask you, but intermittently I heard your lecture. Wonderful, and I enjoyed talking to you yesterday also. Thank you.
Yeah, because the mechanism we have not studied yet. But what other antimicrobial peptides, for example, 1137 in blood, brain barrier, they have seen occludin also, but the mechanism we do not know. So that needs to be studied.
Somehow the synthetic peptide we designed there because, but what is unique in the antimicrobial peptide? They are not able to create protein system. Somehow they are synthesizing them. They are creating some sort of structures.
Yes. Yes, it's a structure based. Like for example, LF37, the cathelicidin, which is the most prominent antimicrobial peptide in the humans. So it is like a really short fragment, like 18 kilodalton protein, like really small. The main is 37 amino acids, but the active part is only 18 amino acids. So that is linear. So the problem is that linear peptide in the normal setup, like for example, in presence of serum, in presence of high salt, it degrades faster. So it always loses activity very fast. When it comes to the synthetic ones, we can change. Like for example, the CD4PP, like a cyclic diamond. So same 18 fragment means amino acid, but it has two. So now it is more circular. So when it is circular, it is more stable. So instead of linear fragment, it is now stable, like circular and stable. So structure has a very strong impact on the stability of the diamond. Yes. Means it is known. LM37 has conserved domain which is active. Yes. You can design other peptides by your own because this conserved domain has a lot of positively charged. So you can design also chemically like a lot of functional like peptides, how they differ. So no, I would not say different from each other in terms of maybe activity. Like for example, LM37 has a lot of positive charge. But when it comes to psoriasin binds, like takes away all zinc and divalent cation, the calcium, zinc, so nutrition is less. So for the bacteria, so a lot of different aspects. Like RNA7 has completely different. It degrades the RNA of the bacteria. It has. That is why we cannot just say antimicrobial peptide. Of course, they are antimicrobial, but we call them as host defense peptides because along with antibacterial activity, they do a lot of things like impact on tight junction proteins, impact on cytokines. So they do have a lot of other effects. So host defense peptides will be the right word than host antimicrobial peptides. Yes. Yeah. Yes. So when we measure from urine, in normal condition, risk means the amount is really low. It was around 20 to 40 nanogram per ml in normal condition. But in the infected patient, when there is infection, risk means is tenfold, like 400 nanogram. Yes. Cationic charge because it easily binds to the negatively charged membrane of the bacteria. So bacteria has negatively charged, these cationic molecules they bind and then they make pores. So then that's a like a classical mechanism of antimicrobial peptide action on bacteria. So they just make pores in the cell surface. It's bacterial cells. Yes. Yeah, I think it should also work against fungus. Yes. So yeah, so work. But yeah, no one has done it because in that paper, in my paper also, the founder of psoriasis was there. So the classical experiment, just simple experiment, 2006 Nature Immunology, what they did, he put in one hand clothes, and in one other hand was empty, and then he put both the hands on an agar plate, and then he saw the empty hand. There was some zone of inhibition. With the gloves, there was nothing. So then he thought, okay, there is something in my skin which is killing the bacteria, and from there he found psoriasis. So that experiment was Jan Stoder is his name. He's in my and he because when we said diabetes compromise, so we sent all our data to him, and then he verified that with his team. He's not doing any active research now, but he's in our paper, and he gave us this chemically synthesized psoriasis to test on these high glucose cells because psoriasis is really expensive. Although like we were in Dharminska, but it was so expensive to buy. So he gave all his resources so that we could prove that in high glucose cells, if we add psoriasis, we can have beneficial effect. So the work which I am proposing, I do not know. Maybe in kidney there is some another peptide. I am not highlighting psoriasis. I have not mentioned anything about psoriasis during my presentation today. I do not know. Maybe there is some other antimicrobial peptides. Maybe LH37. So whatever I saw was on bladders. That is why people, when they work, most of them, they work on bladder polycystitis, so that infection condition system. But what I have focused here is the pyelonephritis. Means, kidney.
What is the skin model?
Sorry?
Skin model.
So we used typical Hackett cells like keratinocytes, and also these are like preliminary data where we have done only in vitro. And now my immediate junior, he is doing on this mouse skin wound model. So like we are giving this MRSA infection on mouse skin, and then we are treating peptide. But that is not my work. I would prefer to use at least not of animals, but I will see, because that is what I had also when I did this infection. Although we took out bladder, I also that time kept kidneys. So then I told my professor that I will work on kidneys and you should not work. So then we have agreed that she will not work on kidneys and I am the one who will work. So I will inherit all the kidneys from her. So we have no agreement. So yes.
So there are different kinds of psychotherapy, different advanced skin. So,
Yeah.
have you checked out?
No, we have not.
Some drugs to try.
Yeah, we have mainly tried some drugs like which was very much focused on Sweden aspect, like for example vitamin D, because of there is high like prevalence of dark periods. Estrogen because of post-menopause. Statin we used, metformin we used. These are commonly drugs, but of course it can be done. And I do not know, maybe those drugs also will have some impact on antimicrobial. No, no. But estradiol also is known to trigger psoriasis, 37, RNS7 in normal cell. So that is also our group paper in the science translational medicine. So that we have shown before, but not in high glucose condition. Mechanism we do not know. Yes. Yeah. 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 And maybe there are some role on some receptors. Yeah. When I was discussing this yesterday with Dr. BC Das in the campus, so he was also telling like a lot of receptors might be playing the role. So in estrogen also alpha beta is there. So yeah.
Somehow notice that despite the connection,
Yeah. The problem first is toxicity, and the second is the stability. That they have come across, like I can say, like for example, diabetic wound, ODL37 is in third phase of clinical trial. So it will come soon. So I cannot say it is not there, but yes. So there are a lot of like other challenges, like for example, stability in serum. Like for example, these peptides are not stable in serum. I don't know how physiologically they are stable, but in the in vitro setup, they are not stable. That is also a challenge to do experiments. So that is the reason we also require all these animals and human samples. Because then at least you can measure at the protein level. You don't need to be worried about. That is the reason we collected urine and we measured the psoriasis.
so maybe they can open up
Yeah, yeah. That is also, yeah. Lot of proteinomal degradation, yes.
so everybody should go to water.
Yes, yes, everyone should go to mountain. I also, because I had this interaction with DDT committee, because they were interested to talk more about this project, because the co-chairperson of this year, Ramalinga Swami, is from ACPGA. So that is why she said she wants to discuss with me on this, because I mentioned in one place that I will be using kidney biopsy. That is where she's like little bit reactive. She said it will be not possible in India to collect kidney biopsy from patients like it. SGPGI Lucknow. She is Amita Agarwal. Sanjay Gandhi Postgraduate Institute. Yeah. I said SGPGI. Yeah. Yeah, so there are a lot of challenges, yes. But of course, mountain for soldiers definitely, like those gels can also, when a bullet will hit them, they just need to put the gel. Just like it will trigger the peptides and it will inhibit the biofilm formation also. Because these peptides, they will inhibit the biofilm formation. That is a major area because what we had worked on urinometer, because we have used some application side of this peptide. That paper is also out in Journal of Hospital Infection. So we have designed one urinometer because in Karolinska Hospital, they have automated urine collecting system. So the urine will come and then when it will reach the threshold, it will be recorded automatically how much that patient has peed. So then the data will go directly to the computer system. So it's not manual. So what we have done, we have used one silicon-based thing so that when urine will pass, it will break the capsule. Silicon will coat this polypropylene complete urinometer and it will prevent this biofilm formation. So that also we have done some work there. So a lot of application aspect is there, but then again the challenge is the stability, toxicity, and all those things. I can propose, like for example, to clean hospital instrument, like surgical instruments. Now in hospital setup, they are using normal water and soap. Instead of that, we use these peptides. We can clean the surgical instruments. So it will not toxic for human. We are not giving them directly. At least this peptide has some other application. It will clean the surgical instrument. So there will not be any coating of this thin layer of biofilm. So that also can be done. Cost will be. So that is why chemical synthesis peptide will be more relevant. We cannot use human antiviral peptide to clean the surgical instruments. Yeah, so we have to always look for us. Yeah.
They used to be anti-problem.
Yes.
But at the same time, they also bacteria.
Yeah.
Some are selective.
Yeah.
So,
Yes, that is what he also asked about Candida psoriasis. I do not know. Maybe there is some effect. And this is a skin protein. It might have some impact on Candida because Candida not colonizes not in skin.
yeah. Skin.
Yeah. Psoriasis can trigger skins. Candida might trigger psoriasis expression of skin. Yeah. Yes. Because yeah, that is why all those work we should do in India because they always clearly differentiate between rich man's disease and poor man's disease. They never work on poor man's disease, like they never work on leishmania. They never work on malaria. In Sweden, only one lab is working in TB. No other is working in TB. They don't have this problem. So that is the reason. So they for vitamin D they work because of this dark, yeah. So vitamin C in India will work on that. No, they are like really healthy country, I would say. Yeah. We collected type 1 diabetic of children samples, only 9 in last 7 years. Only 9. So it's really tough to get done. So the data also which I showed, like it was to collect all those diabetic samples, took really long. There are cases of diabetes, but we really wanted to rule out the effect of other drugs. Patients should not have recurrent infection at that time. We should not take any other drugs. So a lot of aspects also we studied.
When we deem students clinical health,
I can tell also one more small example which will be funny. We collected diabetes sample, but then to get the control sample, same age match was really challenging in Sweden. Like, because we cannot, means doctor cannot call the healthy individuals to come to clinic. I told my boss that, "Oh, let's collect from India. One attendant will come along with the patient. He said will pee, then attendant will also pee. Then only doctor will see. Then we will have control sample and diabetic samples at the same time." All those things can be done in India, but not there. When it comes to the facility, that is what, like, I need a small cell culture unit where I can culture, let's say, renal epithelial cells. My simple experiments will be, let's say, to treat low glucose high glucose, that can be done. And then one bacterial infection facility where I can do infection on these renal epithelial cells. And in terms of measurement of gene expression, to do some microscopy, I can real time is control microscope, like these basic setup. And then, of course, when it comes to animals, that will be the matter part. But to start with, I need all these basic. I do not need any high throughput instrument to start with. I will not, of course, that will be my area. Like, we can treat glucose cells and then we can do, let's say, mass spec and look for new antimicrobial tests. That can be done, but we can send samples outside, we can outsource them.
What kind of ground?
Sorry,
Ground?
this time it has been reduced. Like Ramalinga Swami, like 3 years now. So, but I think it is not quite as so previously it was 5. No, previously it was 5 plus 2, I think. Yeah, and this time it is 3 plus 2.
That's the way.
Yeah, but every year 13 lakhs fixed. Yeah, so 39 lakhs is fixed. Yeah. Yeah, I think
No definition of defects almost will stay.
no. I think no. No, salary is different. Salary is different. Research money is 13 lakhs. Consumables. 13 lakhs is the research money.
It's a very small.
Yeah.
Everything's
Yeah. And that too, they had also a lot of opinion on my project, so they had said, "Oh, we cannot."
So there is the realistic. Whether it is safe for everyone,
Budget is
irrespective of.
yeah, and this time we had an orientation program. So they said also you have to look for ISRO scientists, how they are performing. You cannot say you are in biology, you cannot make new things which will come. So you always look for ISRO, how they are doing. You have to like that. So this time there was proper orientation. They have reduced also the number.
Right, grants.
Yeah. And that is what another discussion, Dr. Amity Agrawal being clinician, she said, because she said, why she also revealed, she has reviewed my application. She said, chance of getting more grants is easier because now I am proposing diabetes and pyelonephritis. She said, you can write diabetes renal scarring, diabetes, let's say diabetic nephropathy on that, infection induced renal scarring, infection induced kidney damage, infection induced nephropathy. So a lot of aspects, like you just change and then changes, like areas can be explored more. So
It will stick to the values.
if I stick to that. Because we need also one compromised host condition, or else it will be difficult to do in the clinical setup. To do in human sample, healthy individuals, it will be challenging because only when it is in need, these peptides will be released. Although these are innate immune molecules, only when it is needed, it will be released. They are ready always to be released, but It will be released when it is.